Okay, hello everybody. In today's lecture, I will try to solve a puzzle that I have posted to my Facebook wall 2 days ago of a letter that a husband is telling his wife that, hey, hi darling, use my ATM card, take any amount out, go shopping, and take your friends for lunch. And the PIN code is can be obtained from this integral, which is apparently very hard for his wife to evaluate. So he's messing up with his wife. And then he says at the end, "I love you, honey." Okay, so I guess he assumes, okay, that his wife is it's impossible for his wife to evaluate this definite integral here and then know the PIN code. So I will try to help her out solve this integral here. I suppose that the PIN code is the first four digits of the result of the value of this definite integral. So to do this, let's start. Okay, so I will call this V. V is the value of the integral, is the definite integral from 0 to 1, 3x cube minus x squared plus 2x minus 4 divided by the square root of x squared minus 3x plus 2, and that's dx. And to solve this, we can notice here that the degree of the numerator here is greater than the quadratic term here. Okay, so if we can find a way to express the numerator here as a function of the quadratic term inside the square root, then it will be easy to simplify the expression and make the integral much easier. Okay, so we'll try to do this. So what I'm gonna do here, this is equal to the integration from 0 to 1. I will try to add this term here, which is the exact quadratic term here, x squared minus 3x plus 2. I will multiply it by 3x to get the 3x cubed term here at in the beginning. Okay, so make this a little shorter. Divided by the square root of x squared minus 3x plus 2. Okay, so now 3x times x squared, we get 3x cubed, that is there. Okay, so we added this term here, so we have to add extra terms to compensate for the things that we've added. Okay, so 3x times x squared, that's 3x cubed, that's there. 3x times minus 3x, that's minus 9x squared. We have minus x squared, so we have to add up 8x squared. So plus 8x squared. And then we have 3x times 2, that's 6x. To make it 2x, we have to subtract 4x. So minus 4x. And then we're left with the constant term here, minus 4. Okay? So minus 4 divided by the square root of x squared minus 3x plus 2. I will put two brackets here and then dx. Okay. Apparently, if we call this term here y, so this is the square root of y, so y divided by the square root of y is equal to the square root of y. So this can be simplified. Okay, here we have the numerator and the denominator and the quadratic term are of equal terms. So we will use the same trick here. We will try to express the numerator as a function of the quadratic term again by adding and subtracting the extra terms. Okay, so this is equal to the integration from 0 to 1. I will put a bracket here, and then 3x times x squared minus 3x plus 2 divided by the square root of x squared minus 3x plus 2, and then I will add another term here, which is equal to x squared minus 3x, that's the exact quadratic term in the denominator, and then I will multiply it by 8 to get the first term here, 8x squared. Okay, and then I will add up the extra terms. okay, divided by the square root of x squared minus 3x plus 2. So we have 8 times x squared, that's 8 squared, that is there. 8 times minus 3x, that's minus 24x to make it minus 4. Then we have to add up 20x, okay? So plus 20x, okay, and then we have 8 times 2, that's 16, to make it minus 4. We have to subtract 20, okay? So minus 20 divided by the square root of x squared minus 3x plus 2, and we'll close the bracket, dx. Okay. Now, now if we think, let me use the, okay, if we look at this, okay, this term here, okay, this term here in marked in yellow, okay, and this term here are equal. They are the same, okay? So, except that this term here is multiplied by 3x and here is multiplied by 8, so we can add that up and simplify the expression. So this is equal to the integration from 0 to 1, 3x plus 8, okay, and we have y divided by the square root of y, that's the square root of y, okay, so that's the square root of x squared minus 3x plus 2, that's the first two terms here. And then here we will try to express the numerator here as a function of the derivative of the quadratic term here. Okay, the derivative is 2x minus 3, so we will add that term. So plus 2x minus 3 divided by x squared minus 3x plus 2. And to make the 2x becomes 20x, we have to multiply by 10. So I will multiply this whole thing by 10. And by multiplying by 10, we have 10 times 2x, that's 20x, that's there. And then we have 10 times minus 3, that's minus 30. We have minus 20, so we have to subtract. To make the minus 30, we have to add up 10. Okay, so plus 10 times 1 over the square root of x squared minus 3x plus 2. Okay, and that's the x. Okay. Okay, now I will use the red color, okay, to simplify things. I will call this integral here I will call this integral here J, without the 10, okay, so I will call this J. Okay, and let's break it down more, so to simplify, to make things clearer. Okay, so this is let me use the black color. Okay, so this is equal to the integration from 0 to 1, 3x plus 8 times the square root of x squared minus 3x plus 2 dx plus this integral here can be evaluated in a straightforward way, because we have we can use the chain rule to evaluate this integral, because the numerator is the derivative of the quadratic term here. So if we take the quadratic term to the numerator, it's going to be x squared minus 3x plus 2 to the power minus half plus 1, that's half over half, 10 over half, that's 20, and we're left with the square root, right? So x squared minus 3x plus 2, and that has to be evaluated from 0 to 1. And then the last term, which is 10, the integration from 0 to 1, dx over the square root of x squared minus 3x plus 2. So I will call this, I will use now the red color, I will call this first integral here I will use the last integral here J. Okay, so and this can be evaluated in a straightforward way. So so this is equal. So this is equal to I plus if we substitute 1 here, 1 minus 3 minus 2 plus 2, that's 0. If you substitute 0, 0 minus 0 plus 2, that's square root of 2. So that's minus 20, the square root of 2, and then plus j, plus 10j. Okay, so that's the v. Okay, so this is the value of the integral, is equal to I plus minus 20, the square root of 2, plus 10j. So in order to evaluate v, we have to evaluate I and j. And I will start by j because we will use the value of j in order to evaluate I. So I will start by j. j is the integral from 0 to 1 dx divided by the square root of x squared minus 3x plus 2. So we call that j. So j is equal to the definite integral from 0 to 1 dx divided by the square root of x squared minus 3x plus 2. And to solve this integral, we can use trigonometric substitution because we can complete the square in the denominator and then use one of the identities, okay, that is suitable for that. Okay, so to do that, let's complete the square first. So this is equal to the square root of from 0 to 1 dx divided by this is equal to square root x squared minus 3x. Then we have to add and subtract the square of half of the middle term, which is 3 by 2 squared, that's 9 by 4, and then we have to subtract 2 minus 9 by 4. Okay, and this is equal to 0 to 1 dx divided by x squared minus 3x, that's x minus 3 by 2 all squared, 2 minus 9 by 4, that's 8 by 4 minus 9 by 4, that's 1 minus 1/4, that's minus 1/2 squared. So we have completed the square here. Now we can use a suitable identity to use that trigonometric substitution. And to do this, let's I will remind you with the trigonometric identity sine squared x plus cosine squared x, and that's equal to 1. If we divided all of the terms by cosine squared x, then we will end up with tan squared x plus 1, and that's equal to 1 over cosine squared, that's secant squared x. Okay, so we have secant squared x minus 1 is equal to tan squared x. So we'll use this formula actually because in the denominator here we have a squared term minus a constant, a squared constant. Okay, so we can assume that this squared term here is equal to secant, let's say secant half secant u. Okay, so let's do that. Okay, so let x minus 3 by 2 is equal to 1/2 secant u, and then let's draw the triangle to make it easy to calculate the other terms. So we have u here. This is the adjacent, okay, and this is the hypotenuse, and this is the opposite side. Okay, so secant u is equal to 1 over cosine. Cosine is the adjacent over the hypotenuse. Since secant is 1 over cosine, so it's going to be equal to the hypotenuse divided by the adjacent side. So the hypotenuse is x minus 3 by 2 divided by the adjacent term, which is 1/2. So let's take this a little bit to the left here. Okay, so the opposite term here is equal to the square root of x minus 3 by 2 all squared, the hypotenuse squared, minus the adjacent squared, that's minus 1/2 squared. And if we notice, this is this term here is exactly the term, the square root here. Okay, so I will write that down. So that's equal to the square root of x squared minus 3x plus 2. Okay, So let's differentiate this this statement here. So dx is equal to 1/2 secant u tan u du. Okay, and then let's substitute that back. Then we have j. We have called it j, right? Okay, so j is equal to. This implies that j is equal to the integration. Dx, instead of dx we put half secant u tan u du, okay, divided by if we substitute secant squared, half secant squared instead of x minus 3, so it's going to be half secant squared minus half squared. That's 1/2. We take the 1/2 squared as a common factor, and then we're left with secant squared minus 1. That's tan squared under the square root. That's tan u. Okay, so we're left with half tan u. So tan u gets cancelled with tan u, half gets cancelled with half, and then we're left with the integration of secant u du, and this is equal to ln the secant u plus tan u. So this is in terms of u, and because this is a definite integral, so we can express it in terms of x. Okay, but we have to evaluate secant u and tan u. Secant u is basically x minus 3 over 2 divided by half, and the tan u is the opposite over the adjacent, which is the square root over half. Okay, so we'll write that down, and this is evaluated from 0 to 1. So this is equal to ln x minus 3 by 2 divided by the adjacent, which is 1/2, and then tan u is equal to the adjacent, to the opposite over the adjacent, which is the square root of x squared minus 3x plus 2 divided by the adjacent, which is 1/2, and this is evaluated from 0 to 1. And let's do the evaluation. If we substitute 1 minus 3 by 2, that's ln the absolute value of minus half over half, that's minus 1, and if we substitute 1 here, it's going to give us 0, so minus ln the absolute value. If we substitute 0 here, it's going to give us minus 3 plus 0 plus 0, square root over half, square root of 2 over half, that's 2 multiplied by the square root of 2. If we evaluate this, then it is going to equal to 1.76274. I will write the long format here. I will use the long format. Okay, 6274 717 4039086. So that's what that is, J. Okay, so we have evaluated J. Okay, now V is equal to, we said V is equal to I minus 20 the square root of 2 plus 10J. So we evaluated J. Now we're left with I. So I is this integral here, the integration from 0 to 1, 3x plus 8 times the square root of x squared minus 3x plus 2 dx. So let's evaluate that, and we call that I. Okay, so I is equal to the definite integral from 0 to 1, 3x plus 8 times the square root of x squared minus 3x plus 2 dx. And to evaluate this integral here, we will use, we can express 3x plus 8 as a function of the derivative. Okay, so we can use the chain rule, derivative of the quadratic term here, so we can use the chain rule to evaluate this integral. The derivative is 2x minus 3, so we will try to express 3x plus 8 as a function of that. Okay, so to do this, I will write this 0 to 1 2x minus 3, that's the derivative of this quadratic term here, multiplied by the square root of x squared minus 3x plus 2. And to get the 3x out of 2x, then we have to multiply by 3 by 2. So multiplying by 3 by 2, we get the 3x, but 3 minus 9 by 2 extra term. So to compensate for that, we have to add up 8 plus 9 by 2. So plus 8 plus 9 by 2 multiplied by the square root of x squared minus 3x plus 2, and I will put 2 brackets here, dx. Basically, okay, the first term here, okay, the first integral is easy because we have this term here, we have its derivative. We can use basically the chain rule to evaluate that. Here we have another integral which needs a little bit of work. Okay, so let's evaluate this first. This is equal to, we have x squared minus 3x to the power half plus 1, that's 3 by 2 divided by 3 by 2. So 3 by 2 gets cancelled with 3 by 2 here, and then so we're left with the value of this integral is equal to square root of the x squared minus 3x plus 2 to the power 3 by 2, and this has to be evaluated from 0 to 1, plus 25 over 2, the integral from 0 to 1, the square root of x squared minus 3x plus 2 dx. And I will call this integral, I will use the red color here to mark this integral here. I will call this integral without the 25 over 2 as k. Okay, so we have to evaluate that. Okay, but let's evaluate this integral here. If we substitute 1, that's 0. Okay, if we substitute 0, then it's going to be 2 to the power minus 2 to the power 3 by 2. That is equal to minus 2 multiplied by the square root of 2. Okay, plus 25 over 2 times k. That's the value of I. Okay, and I will put a box here to mark that. Okay. Okay, so to evaluate I, we have to evaluate k. Let's evaluate k. K is integral from 0 to 1, the square root of x squared minus 3x plus 2. So to evaluate this, let's write it down first. Okay, so k is equal to the definite integral from 0 to 1, the square root of x squared minus 3x plus 2 dx. And this basically can be solved using the integration by parts. We can set u as the square root of x squared minus 3x plus 2. Okay, and then we have to differentiate that. Okay, so du is equal to the derivative of the square root, as we learned from calculus, is equal to the derivative of what is inside the square root. That's 2x minus 3 divided by twice the square root of itself. 2 square root itself, x squared minus 3x plus 2, and then dv is equal to dx, and that's, we have to integrate that. V is equal to x, and then we have to go like this. We have to multiply this this times this minus the integration of this times this, but we have to put dx here. Okay, so the value of k is equal to x multiplied by the square root of x squared minus 3x plus 2, and this has to be evaluated from 0 to 1, minus, let's take this half here outside, so that's minus 1/2, the integration from 0 to 1, and we're left, and let's distribute x times 2x minus 3, that's 2x squared minus 3x. Okay, that's 2x squared minus 3x divided by the square root itself, which is x squared minus 3x plus 2, and that's dx. Okay, and we can use the same trick that we used in the beginning to evaluate the second integral here. This integral here basically and apparently is equal to 0, because if you substitute 1 and 0, it's going to be equal to 0. So this cancels out. Okay, so we are left with minus half the integral from 0 to 1. And to solve this integral here, we can use the same trick. Okay, we can express the numerator here as a function of the quadratic term here. So what I will do, I will add up terms. Okay, I will do this. Okay, so x squared minus 3x plus 2, and to get the 2 here, I will multiply this by 2. Okay, and then divide by the same quadratic term, the square root, x squared minus 3x plus 2, and then 2 times x squared, we have 2x squared. 2 minus 3x, that's minus 6. To make it minus 3, we have to add up 3x. Okay, so plus 3x. Okay, and then we have 2 times 2, that's 4 plus, okay, so we have to subtract that, minus 4. So we have to subtract that, minus 4, divided by the square root itself, x squared minus 3x plus 2, and I will put 2 brackets here. Okay. If we notice that this is equal to 1/2 the integration from 0 to 1, if this term here is y, this is the square root of y1, y over the square root of y is the square root of y, so we are left with 2 times the square root, x squared minus 3x plus 2, and then this term can be evaluated. We can use also the other trick also. We have to express this term here as a function of the derivative of this quadratic term here, which is 2x minus 3. Okay, so we'll add up that and compensate for the difference. So plus 2x minus 3 divided by the square root of x squared minus 3x plus 2. So to make the 2x become 3x, we have to multiply by 3 by 2. Okay, so we have 3 by 2 times 2, that's 3x, that's this term. 3 by 2 minus times minus 3, that's minus 9 over 2, that's minus 4.5. We have to make it minus 4, we have to add up half. Okay, so plus 1/2 1 over the square root of x squared minus 3x plus 2, and that is dx. Okay, so now going back to if we notice here, let's look at this term here. This term here is basically k, or twice k. Okay, so this integral here is twice k. Okay, this integral can be calculated using the chain rule, straightforward. This integral is the same as j that we evaluated in the beginning, so we can use that value that we calculated in the beginning. Okay, so this is equal to 1/2 minus 1/2, okay, times 2k, that's the integral, plus this integral here. If we can use the chain rule to evaluate. Okay, this integral. If we take this square root to the numerator, it's gonna be minus half plus 1, that's half over half. So we're left with 3 times the square root of x squared minus 3x plus 2 has to be evaluated from 0 to 1 plus j over 2. Okay, and so basically k is equal to minus k minus 3 by 2. If you evaluate this 1, that's going to give us 0. Okay, minus, if we evaluate 0, that's going to give us square root of 2 plus or minus j over 4. Okay, so k is going to be half. If we take this k to the other side, it's going to give us 2k, so we have to divide by 2. So k is equal to 3 by 4 square root of 2 minus j by 8. So to evaluate k, and we already have evaluated j, so we can calculate k now. So basically k is equal, and I have calculated this, k is equal to 0.84031677 5024936. So that's k. Okay, so now we have evaluated k. Okay, so now we can evaluate ki. Okay, because we needed k to evaluate I. Now we calculated k, so we can evaluate I. So I is equal to minus 2 times the square root of 2 plus 25 over 2k. So now we can calculate I. And then we can calculate v at the end. Okay, so this implies that I is equal to minus 2 square root of 2 plus 25 or 2 over 2k. And this is by substituting the value of k here, we can calculate I as 7.6755 325 325 630 630 655 65504, and that's the value of I, and I will put a box there. So this is the value of I. Now we are left with the value of v. This implies that v is equal to I minus 20 times the square root of 2 plus 10j, and if we evaluate that, if you substitute I in j there, then we will end up by minus 2.8 I'm sorry 98981 2, and the rest is not necessary. So based on this result here, we can know the PIN code. This implies that the PIN code of the card is 2981. So that's the PIN code. So now the wife can use this code, and she can spend as much money as she likes. Thank you everybody for watching.